Lucian.
And I'm Micah, and today we're going to teach you about continuity.
We're going to teach you about the informal and formal definition of continuity.
And we're also going to show you the checklist and go through some examples.
Hey, I'm Adam.
For continuity, there's an informal definition and a formal definition. The informal definition is a function f is continuous at x equals a if the graph of f contains no holes or breaks at x equals a. In other words, the graph near x equals a can be drawn without lifting a pencil. So the formal definition is a function f is continuous at a if the limit as x approaches a of f of x equals f of a. If f is not continuous at a, then a is a point of discontinuity.
Okay, this is our example. This graph has 3 points of discontinuity. The first point, which fails to be continuous, is 1, and f fails to be continuous at 1 because f of 1 does not exist. The next point of discontinuity is at 3. F fails to be continuous at 3 because f of 3 does not equal the limit as x goes to 3 of f of x. And the last point at which f fails to be continuous is at 5, and it fails to be continuous because the limit as x goes to 5 of f of x does not exist, and that is because the limit as x goes to 5 from the negative side of f of x does not equal the limit as x goes to 5 from the positive side of f of x. Okay, these are some continuity rules. If f and g are continuous at a, then the following functions are also continuous at a. Assume c is a constant and n greater than 0 is an integer. So these following functions are going to be continuous. The function f plus g, f minus g, a constant times f, f times g, f divided by g, and f of x to the nth power.
Alright, so what we're going over is the continuity checklist. And basically what this means is to ensure that your graph or your line is continuous at each point. And the checklist is really that it's defined, and what we're talking about that is that it's part of the domain of f. So essentially what we're saying is that there are no holes in this line. We have to assure that x, as the limit as x approaches a exists, which basically means that as x approaches this particular number, that it doesn't get wonky and go one way or another. The third in our continuity checklist is that the limit as x approaches a, that f of x is equal to f of a, which basically means that the value as x approaches that number is that number. So as you get close to it, the limit of it is equal to the number that it's approaching. It isn't going to approach it and then drop off or jump up.
Meet Micah. Micah is walking. And since she's walking through f of a without stopping, that means f of a is defined. Meet Micah again. She's walking. Oh no, there's a hole. So, since Micah jumped over the hole, that means f of a is undefined, which makes the line discontinuous.
Hey, Adam, you want to meet at point A?
Sure!
Okay, Adam's approaching from the negative side, which is the left side, and Micah is approaching from the positive side, which is the right side. So since they both meet at point A, that means that the limit as x approaches a of f of x exists. Okay, Adam is he's coming from the negative side, which is the left side, and he's going to point A. And Micah is coming from the positive side, which is the right side, and she's going to point B. So since they're both going at different points, the limit as x approaches A of f of x does not exist.
Lucian and Adam are both approaching A. They end up at the same spot of 2, therefore the limit as x approaches A of f of x equals 2. However, f of 2 is undefined. F of A equals 6.